This example comes out of section 5.4, Equations and Graphs of Trig Function. In this question, we're asked to graphically determine the general solution for this trig equation, 16 equals 6 sine pi over 6x plus 14. Most direct way to do this would be just to graph each side of this equation. y1 equals 16, y2 equals 6 sine pi over 6x plus 14. We want to make sure we graph it for at least one full cycle, if not a couple full cycles, since we are doing the general solution. Window settings would make sense to make sure that you at least had your Y window going up to or past 20, since the maximum of this graph would be 20 and the minimum would be 8. This graph is also going to have a period of 12, so if you at least go 12, but maybe even 24 units on the x-axis, you'll be able to see your graph fairly well. So two full cycles of this sine graph have been drawn here, and the horizontal line at y equals 16 are there. The first thing I'd look for is the first intersection point, so I'd press second trace intersect, and I find that point to be at approximately 0.65. Find the second intersection, and you find that that one is at about 5.35. If you keep going and find the next one, the next one, the next one, you can start to see a pattern developing, and that is that the first two answers were really enough, because once you realize that the period of this graph is going to be 2 pi divided by pi over 6, or in other words 2 pi times 6 over pi, which is 12 units. As soon as you find your first two answers, you could say that the general solution is x equals 0.65 plus 12n, and x equals 5.35 plus 12n, where n is any integer, and that would actually include all the answers, because every answer from there is going to be 12 units to the left or to the right of those original two answers that you found. So there's a general solution determined graphically in this case, and again notice that we use radians unless we're told otherwise, and so these answers are in radians.